Hey everybody, today's notes concept is all about magnetism. This is our topic for our notes today. And you know what? There's only one more to go after this. Thank goodness. So make sure you write this title down in your notes in the input side of your notebook. And let's get this thing done. All right, your essential question for today is, why are magnets so important? All right, why do we even care about magnets? What do we use magnets for? All right, by the time you get through your activity today, you should be able to answer this question. Okay, why are magnets so important? Again, the title to these notes is Magnetism. When you go to turn this in, you'll turn it into eBackpack into the slot that says Magnetism Notes and Shutter Foldable. All right, so magnetism. Magnetism refers to the properties and interactions of magnets in which there is a force of attraction or repulsion between like or unlike poles. All right? And the strength of force between two magnets depends upon the distance between them. You can see here magnetic field strength is the strongest when the magnets are closer together. As you pull the magnets farther apart, the force is still there, but it does reduce in strength. Okay? Magnetism. As previously mentioned, magnets exert a force, and this is a field force, which exists whenever the magnets are not in direct contact with each other. Okay, so the magnetic field is a force on other magnets and objects made of magnetic materials. The strongest force, again, is closest to the magnet. It's the one that has the shortest distance. And what you see here, this is a bar magnet. We see the North Pole, we see the South Pole. And around this bar magnet have been arranged iron filings. Iron is attracted to magnets. It is a metal. And what we see is this is the general idea of how we can understand magnetic field. All right. These iron filings have lined themselves up that are far away from the magnet in such a way that they're on this side, their northern pole is attracted to the south pole of this magnet. And over here, the south part or the southern pole of these iron filings is attracted to the north. And the ones that have actually made it to the magnet are very much so attracted. They have created that real strong magnetic force. All right? All right, all magnets have a north pole and a south pole. Okay, just like the Earth. The Earth rotates on its axis such that the north pole is upward and the south pole is downward. All right? And that is the north magnetic pole and south magnetic pole. If we have a compass, a directional compass that is magnetic, it always points to magnetic north, and that helps us with navigation and directions and stuff like that. Okay, and that's because of the magnetic materials being attracted to the Earth itself. When it comes to the poles, and just like charges, opposite poles attract to each other. So south pole end is going to be attracted to the north pole end of another magnet. And the same poles will repel each other. So if you try to stick two south pole ends of magnets together, they're going to push away from each other. They do repel. And now in terms of magnetic materials, there are really only a few metals such as iron, cobalt, and nickel that are attracted to magnets or can be made into permanent magnets. There are some other metals that have slight magnetic properties, but these are the ones that can really be turned into permanent magnets. Now the reasons why different substances, different materials can be turned into magnets is because of their magnetic domains. Magnetic domains are groups of atoms within the material that align with the magnetic poles. All right, so they can line themselves up and shift and turn within the material. Yes, even within metals. And this happens, and it's so small for us to see, we can't really see it. But next week, when we do our electromagnetic lab, we will get to experience this as we make electromagnets. Okay? Permanent magnets are made by placing a magnetic material in a strong magnetic field for a long time. And this forces the magnetic domains to line up. Okay? Now these man-made magnets down here, with neodymium magnets being the strongest, these materials have been exposed to a magnetic field for a long period of time. So that should also lead you to think that over time these magnets will lose their magnetic properties too. Okay? I'm sure you've realized that, like this little sticky tape that's on the back of refrigerator magnets oftentimes. These are lightweight magnets, and sometimes they lose their magnetic property. Okay? And the same thing can happen with those magnetic strips that are on the back of your debit card or your credit card too. That can lose its magnetic properties. It's one of the reasons. There are many other reasons, but that's just one of the reasons why we have to have our cards renewed and replaced over a certain period of time, because that magnetism has a tendency to become demagnetized. Okay, so you're going to answer that essential question as you get through the foldable activity today. Think about it. It's more of an application question. Make sure you answer it, and then turn your work in when you're done, when it's all said and done. All right? Have a good one.